If you're studying for the MCAT, amino acids are one of the highest yield topics you'll ever see. They show up in the biological and biochemical foundations of living systems section, and they're tested in multiple ways: structures, properties, classification, and how they form proteins. The MCAT isn't just asking you to memorize, it wants you to understand how amino acids interact, fold, and ultimately determine protein function. Master this, and you'll grab points every time this topic shows up. Amino acids, the building blocks. There are 20 standard amino acids that make up nearly all proteins. Every amino acid has the same base: a central carbon, an amino group, a carboxyl group, and a variable R group. It's that R group that makes each amino acid unique. Classification, think side chains. MCAT loves this. Amino acids are grouped by R group properties. Nonpolar. These are hydrophobic, so they don't like water. They usually end up buried inside the protein core. Polar. These are hydrophilic, so they can interact with water and often sit on the protein surface. Acidic. These carry a negative charge at physiological pH. Basic. These carry a positive charge at physiological pH. A quick example: lysine is basic and positively charged, while glutamate is acidic and negatively charged. Peptide bonds. Proteins form when amino acids link together. The carboxyl group of one bonds with the amino group of another, releasing water. That's the peptide bond. Remember, peptide bonds are strong covalent bonds, not easily broken except by hydrolysis. Levels of protein structure. Proteins have 4 levels of structure. Primary structure is just the amino acid sequence. The order is everything. Even one mutation can change function, like in sickle cell disease. Secondary structure includes alpha helices and beta sheets. These are stabilized by hydrogen bonds along the backbone. The MCAT often hides this inside passage questions, so keep an eye out. Tertiary structure is the full 3D fold of a single polypeptide. Here's where side chain interactions matter most. Hydrophobic collapse, hydrogen bonding, and disulfide bridges all shape the fold. Quaternary structure is when multiple polypeptide subunits come together. Hemoglobin is the classic MCAT example. Protein functions. Proteins aren't just structural, they're enzymes, receptors, transporters, antibodies. If there's a job in the cell, a protein probably does it. Denaturation. Proteins only work if their shape is intact. Heat, pH changes, or chemicals can unravel them, destroying function. Think of cooking an egg. Once it's denatured, it doesn't go back. The MCAT may test how changes in environment affect protein activity. MCAT tip: know your amino acids cold. Their structures, whether they're polar or nonpolar, acidic or basic. This knowledge is tested directly in discrete questions and indirectly in biochemistry passages. It's one of the most efficient study investments you can make. So here's the key takeaway: amino acids aren't just 20 things to memorize. Their properties explain how proteins fold, function, and sometimes fail. On the MCAT, that means recognizing side chain chemistry, understanding protein structure levels, and predicting what happens when conditions change. High-yield, high-scoring material if you prepare the right way. With that said, here are just a few of our student success stories. Students who improved their scores and even got into medical school. If you're preparing for the MCAT, click the link below to get started with your own preparation. We specialize in helping students reach a 515+ score guarantee, and we'd love to help you too. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.